Is this event horizon image accurate? Webb scans Vega for planets. Another problem with Voyager-1. And a supernova space dandelion. All this and more in this week's Space Bites. This is one of the most famous astronomical pictures that have ever been taken. And you must be familiar with this picture. You are looking at the event horizon of the supermassive black hole at the heart of the Milky Way. And this image was made by telescopes around the world, imaging this tiny spot in space together. And then enormous amounts of data was brought together into one location, crunched through supercomputers to try and make sense of everything that all of these telescopes are seeing, to merge it into a single image. And we got this with a very obvious ring surrounding this dark region in the middle. This is the event horizon of a black hole. But is it actually what you would see if you got much closer to the black hole? A team of astronomers from Japan think that maybe not, that in fact, the way the data processing was done isn't exactly accurate, and they came up with a different result after they crunched through the data. Essentially, they used a different analysis method for evaluating the data that was returned by all of the telescopes. And what they found was that their image was more lopsided than what had been previously reported. And what they found is that it is elongated in the east-west direction, with the eastern half being a lot brighter than the western half. And what this tells them is that this accretion disk, this material that is surrounding the black hole, this is going at 60% the speed of light. And they also think that it's off at an angle of about 40 to 45 degrees. So how can we resolve this? Well, there's going to need to be another picture. The event horizon is going to need a reshoot. And this is in the works. There have been continuous observations of the supermassive black hole year after year. We got additional polarization data. And so I'm sure we will get a better image coming out eventually. And as new telescopes are added to the network, maybe eventually they go to space. And as the methods of crunching down the data get better and better, we will finally get to a place where we're very comfortable to know that what we're looking at is the event horizon of a black hole. I mean, I guess we know that it's the event horizon of a black hole. It's just exactly what it looks like. All right. Scanning Vega for planets. Vega is one of the brightest stars in the Northern Hemisphere. It's a star that I am very familiar with. It's part of the summer triangle. And so every summer when I was doing my amateur astronomy, I would go out and I would find the summer triangle. And then a lot of really interesting objects are collected around these three different stars. And the brightest one is Vega. Now, this is a dramatically hotter and brighter star than the sun. Its surface temperature is almost 10,000 degrees. Compare that to the sun, which is about 5,800 degrees. It's about 2.1 times larger in diameter than the sun, and just puts out an enormous amount of light compared to the sun. And yet, back in 2013, astronomers got a hint that there is a debris disk around the star. And now fast forward to today, and astronomers have the James Webb Space Telescope, which is great for looking at dusty disks around stars. And so they observed Vega, imaged the disk, but also were looking for any hint of a planet orbiting within the disk. They found 3 candidates, but nothing really firm. One of the sources looks like it could be between 1 to 3 times the mass of Jupiter. But again, the astronomers were very clear to say there is nothing conclusive here, that more observations are necessary. But this is really interesting because, we know that the smaller red dwarf stars have planets. We know that stars like our sun have planets. What about the big stars, the hot stars, the ones that live much shorter lives? Do they still have planets? They actually would have habitable zones as well. So theoretically, you could have planets that are in the habitable zone of giant stars. Of course, they'd only have a few million years to live, so who knows how far life could get along on one of those planets. An alien signal decoded. In May 2023, an alien signal came from space and arrived here on Earth. It was picked up by 3 radio telescopes, and then teams around the world set furiously to try and decode it. Now, is this the plot of Contact? Did we actually receive a signal from an alien civilization? No. The signal was sent from the European Space Agency's ExoMars Trace Gas Orbiter mission. at the orbit of Mars. It was done as a simulation. What would happen if an advanced civilization in another star system did send us a message? How would that look to our Earth-based radio telescopes? Now, what makes this really cool is that it was also an art project. A researcher made a message and then encrypted it and then sent it out to the Mars mission, and then it was transmitted back to Earth. And so 5,000 participants around the world tried to decode what the message was. And finally, this month, a father-daughter team in the US were able to finally crack the code. And so the message that they got contains 5 clusters of white dots and lattices against a black background. And it suggests cellular formation and life in 5 amino acids. So, is that the kind of message that the aliens might send us? Who knows? And would they use that kind of way of encrypting it? Who knows? But the point is that if we did receive a signal, that's kind of what it would seem like. And that's sort of how the process of humans on Earth attempting to decode it. So I love it both as sort of like a scientific proof and as an art project. NASA's solar sail is still tumbling. We've been reporting quite a bit on NASA's Advanced Composite Solar Sail System, which was launched earlier this year. And NASA has been taking the deployment of this solar sail very carefully. It wasn't until September that they finally extended the booms and the full solar sail. And what they found was that there was a bit of a problem, that one of the booms was a little bit bent. What they think happened is that when they were fully tightening the solar sail at its largest extent, that it caused one of these booms to bend. Now, NASA says that it isn't a big deal, and in fact, the spacecraft is still tumbling a little bit since when they deployed the booms. They're going to be using the light pressure of the sun to stabilize the spacecraft and then continue with a whole series of tests. But like I said, NASA is taking this process very slowly. They want to understand how this thing behaves as it's tumbling, understand what slight changes can be made to stabilize these movements, and use this as knowledge for future solar sails. And I am so excited about solar sails in general. I mean, this is a way that you can passively gain propulsion purely by collecting photons that are coming from the sun. And you can imagine this future where every single spacecraft has one of these solar sail systems attached to it as a secondary propulsion system that could be used for maintaining its attitude or shifting to higher orbits and just maneuvering around the solar system, either sort of in connection with its existing propulsion system, or if its main propulsion system goes offline. It's kind of like having to have an oar in your motorboat. So I'll keep you posted as we learn more about this solar sail. More trouble for Voyager-1. Now, the Voyager spacecraft are continuing to produce less and less power over time. This is partly due to just the decay of the plutonium on board the spacecraft, and this is partly due to just that the thermocouple on the spacecraft are getting older. But what this means is that NASA is constantly having to communicate with the spacecraft and having them to juggle the various instruments on board and then the other systems to try and keep their entire energy budget within the capability of the radioisotope thermoelectric generators on board. And so earlier this month, engineers at NASA sent a command to Voyager-1 to turn on one of its heaters to keep instruments on board the spacecraft warm. And then they waited for an acknowledgement, and waiting takes a while. These spacecraft are 24 billion kilometers away. It takes 23 hours for each leg of the journey, 23 hours out and 23 hours back. And they didn't receive the reply signal like they were expecting. And so they waited, and then they tried scanning other frequencies with their radio telescope and found a faint signal coming in from Voyager-1's auxiliary band. And this is a communication system that hadn't been used on Voyager-1 for decades. So what happened? So when they asked Voyager-1 to turn on its heater, it triggered a fault system, and that caused Voyager-1 to automatically go into a lower power mode. It turned off its main X-band transmission system and switched its communications to the S-band system, which is lower power and lower bandwidth. But now NASA is able to regain contact by listening very carefully for these S-band signals. And over time, they're going to continue to reprogram it, try and manage the power as it shifts into this new phase. But once again, this is another reminder that these spacecraft are getting old, and these regular science updates that we're getting from them, one day, not too long, we'll hear the last from them. Every week we do a vote on our channel where you tell us what you thought was the best space news of the week. And the winner this week was the new images coming from the Euclid Space Telescope. So thank you everybody who voted. Now we post a vote onto our community tab within 24 hours of when we release the new episode of Space Bites. So if you want to participate, you can either just be randomly scrolling through YouTube, you'll see the vote, or go to the community tab and then vote on a bunch of different polls, and that will remind the YouTube algorithm that you want to see us. Of course, you should also subscribe and click on the notifications bell and watch all our videos and just train the algorithm. Another subsurface ocean in the solar system. One of the most intriguing places to search for life in the solar system is Europa, and that's because you've got this thick icy shell surrounding a vast ocean of liquid water. And since that first sub-ice ocean was discovered at Europa, astronomers have been finding that many of the objects in the solar system are very similar. I mean, at Enceladus, we can see this water being sprayed out into space, and it's believed that the Voyager-1 spacecraft saw geysers at Neptune's moon Triton. And then when looking at the surface features of many different moons in the solar system, astronomers see the same kind of thing. And so now it's believed that there's probably a sub-ice ocean at Pluto and Charon and many of the other Galilean moons and other Saturnian moons. Like, they're everywhere. But now an extremely small icy moon also appears to have a subsurface ocean. And that's Miranda, which is the 5th largest moon of Uranus, which is really small compared to a lot of the other moons that I mentioned in this segment. So researchers were looking at the surface of Miranda, and it has these really interesting features, these sort of linear scarps, these lines that appear to have slumped down. At the time when the Voyager-2 spacecraft took these images of Miranda decades ago, researchers saw that this was really interesting and were trying to explain it. But now, with modern computers, they can run simulations. And so researchers said, well, what if a subsurface ocean is causing these surface features on Miranda? And so they ran through a whole bunch of simulations to find out which one would give them the kinds of conditions that they saw. What they found is that if you have an icy surface that's about 30 kilometers thick, surrounding an ocean that's about 100 kilometers thick, surrounding a solid core, then you can get these kinds of features on the surface of Miranda. So oceans are everywhere across the solar system and probably the universe. And then a methane crust for Titan. So speaking of fascinating moons with interesting surface features, let's take a look at Titan, which is the largest moon of Saturn and the 2nd largest moon in the solar system. And so once again, planetary scientists were studying the surface of this world, and one of the things that they noticed was that it has a lack of large craters. And because it's such a large moon, you would expect it to be bombarded by icy objects, asteroids, comets, things like that, and you would see the results all over the surface, but they don't see that. And so some process is eroding or refilling those craters and making them disappear over relatively short periods of time. And so once again, astronomers have had images of the surface of Titan thanks to the Cassini spacecraft for more than a decade, and yet are still struggling to answer why it has this strange lack of craters. One thing that makes Titan very different from a lot of other worlds in the solar system is the presence of methane. Now, we know that it has the methane lakes on the surface of Titan. We know that it rains methane, but it also has a version of methane called methane clathrate, which is beneath the surface of Titan. They tried a bunch of different calculations, and when they hit on a layer of 5 kilometers, they found that the methane then removed these surface features over a relatively small amount of time. They call this relaxation. And at 5 kilometers, then these craters relax, flatten out, smooth out within about 1,000 years. And that would perfectly explain why we don't see a lot of large craters on the surface of Titan. And by the way, we're going back to Titan with NASA's Titan Dragonfly, which is launching in just a couple of years, although it won't be there until the mid-2030s. A space dandelion. Although we haven't had one recently, we know that supernovae go off within the Milky Way from time to time, every couple of centuries. And there's some really famous examples of this seen by astronomers throughout history. One very famous one happened in the year 1181, and this was seen by Chinese astronomers and European astronomers, and this was written down in many history books. But figuring out exactly what happened has remained a puzzle for quite a while. It wasn't until 2013 that astronomers finally found the remnant left behind after the supernova went off. But subsequent observations in the area around the remnant led astronomers to think that in fact this was a very rare event, a collision between white dwarf stars, sort of like a scaled down version of a kilonova. And so now new observations show that around the area where these colliding white dwarfs happened, you've got material that is being kicked out at about 1,000 kilometers per second in all directions. And so astronomers liken this to a space dandelion, that you've got this shape where you've got these chunks of the white dwarfs that are being thrown out in all directions. They're leaving these trails of debris behind them as they go.
Oh, yummo! A dandelion. Must be the last one of the season.
I've got to say, I'm jealous at the ancient astronomers who saw two white dwarfs collide in the sky, as it looked like a bright star to them. But, we haven't had a close supernova go off in modern astronomy. The closest that we know of is the one that happened in the Large Magellanic Cloud in 1987. And we are due for a relatively close supernova to go off that we can study very carefully. Now, while you're watching this week's episode of Space Bites, I am writing my weekly email newsletter, The Guide to Space. And that's where I get to report on a whole bunch of stories that are above and beyond what you're seeing here this week. For example, astronomers have found the fastest spinning neutron star. Comet S1 didn't survive going past the sun, and astronauts could take an asteroid ferry from the Earth to Mars. These are just a few of the 30-ish or so stories that are in my newsletter every week. And so if you want to get access to that, it's completely free. I write every word. There's no ads. You can subscribe. Go to universetoday.com/newsletter to sign up. Now, we went live with the first of our telescope live streams this week, and I want to give you some updates on what's happening with that. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Gilton, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Roebuck, ScienceWorldRecord.org, SpiderSwap.io, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So this week was pretty cool. On Sunday night, I went live with our brand new streaming telescope. This is a Celestron Origin telescope. It's a smart scope that goes very quickly and allows us to image the night sky and share it with you. And this is very reminiscent of back in the day when I used to do the virtual star parties, where we had astronomers around the world collecting together, and we would look through their different eyepieces at what was happening in space. And I've always wanted to bring this thing back, but it's always been so complicated, so dependent on people having good weather and gear that cooperates. And now we finally have what I think is just the perfect solution. And this is that our good friends at Starfront are letting us use one of their telescopes as much as we like. And so we're going to be able to now put out regular telescope live streams with me and other people from the Universe Today team, but then also other astronomers, special guests, celebrities. With this first test night, I think I captured about 15 images over the course of an hour, just learning how to use the telescope. And that is so much faster than anything I've done ever before. And so we are now in the process of starting to build in all of the features that we want, trying to make it look the way we want it to look. And so you're going to see us rapidly improving this process. And we're just going to do this every couple of nights until we feel like we're really happy with it. And then we'll stabilize it and come up with a weekly event where people can come together. So I apologize. These are going to be random. I'll try to give you advance notice when I can. They're definitely going to be in the evening on the West Coast. We're just kind of dependent on where the telescope is located. But it was a really good time. I'll put a link so you can check out the first version that we did. And hopefully by the time you're watching this, we'll have done a second one and more coming. So stay tuned. I'm really excited. I can't wait to share the universe with you directly. All right. We'll see you next week.